everyone. As mentioned, my name is Austin. Just a little bit about me. I do work at Kaiser. My group kind of specializes in going out and taking like a 5-month or 6-month use case within the organization, since it's so large, and then implementing at least a preliminary solution, and then maybe going back and refining that into an actual product. Being a data scientist, it's always useful to mention the tools that we use, and there's nothing like exceptional about that. I just would mention that, like, for my job, emails are actually something really important to master. And I do enjoy backpacking and running. So I'm just going to briefly go over the scope. So my talk is a little bit business, so hopefully I won't bore anyone too much. But I think it's important to mention because, you know, in data science, like a lot of people talk about the 80-20 rule, where, you know, 80% of your work is preparing the data, and then, you know, the 20% is the modeling. I would say in like healthcare, you maybe have to add on, like, you know, decide how you want to split it, but add on like maybe another 10% out of your overall to 10 to 20% of actually like getting a hold of the data and stakeholders and ensuring privacy and everything else. And I would say that's actually pretty conservative. But I'm going to be talking about how you would approach, you know, maybe a product that we're actually kind of working on right now, kind of the motivations for it, where the data is coming from, kind of the scope of what the problem we're trying to attack, and then where we are. So just a quick overview of why data science is difficult. I kind of have it bucketed into 3 categories. The one everyone would probably like go to first is like privacy. I have it listed there twice because it comes up pretty much every single day. Whether it's data at rest or data in transit, figuring out how to encrypt it, it comes up all the time. And it's very difficult to anonymize. You'd think, you know, we'll just, you know, take out names and patient IDs. But actually the market value, black market value of like your MRN, your medical record number, I think is like a factor, somewhere around like 10 times more valuable than your like social security number. And so, you know, any hint that you could be, something could be traced back to you has to be eliminated. It's the new gold, so, you know, people are, all that privacy makes it very difficult to get, right? So, you know, it's like an economics problem. People are trying to get a hold of it, and, you know, even if you have, say, like a larger company and they say, well, you know, we'll implement a solution for you, it'll be great. And then, but then what happens with the model they trained? You know, can it be still traced back to, you know, the privacy issues? Who owns the data? Does the patient actually, you know, you as a patient, you're providing the data, do you get anything from that? So all those issues. And then you actually get to the data where it's, you know, really messy. You know, you have legacy systems that haven't been updated in forever, and then you're trying to join all this information, you know, just for like a simple visit. You can be joining like, you know, 10, 20 tables easily, and you figure out, and everything is time bound, right? So just a few of those kind of lead to what I call the 3 commandments of data science and healthcare. The first being you have to provide a client's data solution without the client's actual data. Number 2, know what the client wants when they have no idea what they want. And then make linear regression seem as difficult as deep learning, and deep learning as easy as linear regression. That may be a little cryptic, but what I mean by that is, you know, all your senior level people are going to be familiar with probably both, right? But they're going to think linear regression is fairly easy to understand, but it has like lots of nuances for anyone who's like familiar with it, right? And you can easily make critical mistakes. The flip side of that is, you know, their interaction with like deep learning, for example, is in a magazine they maybe read in the back of like an airline seat, right? Or some periodical that comes in. But there are some like, you know, fairly basic things that deep learning does really well. And, you know, it could be saving lives. So making sure that you're communicating like the different layers of like complexity and how easy it is to implement a solution is critical. That leads me to what to the kind of actual problem, I guess. So, you know, actually start with B, where we're trying to go. There's obviously many use cases, everything from physicians nowadays. So physicians are bombarded with more electronic emails, right? So, and maybe they get incentivized to answer those emails, maybe they don't. That's just one example. Another critical example would be, whenever you go into a patient room, can you have any sort of, capture any sort of meeting from the conversation that have your doctor, right? So your doctor is like taking notes at the same time they're trying to decide if they're going to prescribe you medication, at the same time try to, act empathetic towards you. So there's like some augmentation that can go on there, right? But you have to start really simple because you have to get a solution out, with all these privacy concerns, which leads to open source data because, something I can share with you today, I can share with a leader in a health organization. So where do you get text data for discussions about your health with medical professionals that will not violate anyone's privacy? Being a millennial and not sure what to do next, of course I went to Reddit. And so there's actually a nice subreddit called AskDocs. It's actually interesting because there is basically verified clinicians. I'm not sure that's super enforced, but I know that they do have to send in examples of either their medical degree or some proof that they're practicing clinicians. So there are, it has some legitimacy to it. It's not just a bunch of people saying they have home remedies, right? So I pulled data from its actual BigQuery. It's all open source. Data is from 2014 to 2018. Percentage of kind of posts that go on by the medical professionals are roughly half, so that's good. That means, for every post that's online, there's going to be a response. About 30 threads. So a thread, for anyone who's not familiar with Reddit, is basically, where you go on, you post something, and then hopefully there's some interaction that kind of goes onto that initial post. 26,000 users, 16,000 medical professionals. I will say that, for Reddit, it has every color of conversation under the rainbow. But for this data in particular, there were I would say more than a fair share of probably kind of male specific issues, and I'll just leave it at that. Just kind of the topics that were in this, what is people talking about? This is a clustering technique based on word embeddings. So you can see that, and so this is not a lot. There's no bias going into this. So you can kind of say how much garbage is actually in this data, right? It's an online forum, and there's some kind of medical things in there, right? You have symptoms, you have blood results. These are my inferred cluster names, by the way, but hopefully you agree. You have exclamations, you have health institutions, meds, people are talking about foods, right? All things that I would think, would be something, good to pull text data from. Another way of looking at the data is kind of, it's called TSNE. It's stochastic named entities, if anyone cares. But basically, it's a projection of all these words onto a two-dimensional space with the distance from words kind of preserved. So words that are closer. Hopefully you can't. No, you can't see anything. I did label those on purpose so that basically kind of the words at the center, are kind of words that would occur in the same context or area, and words that are far apart usually don't. And I think a plot like this, it can be really susceptible to, I think it's pronounced apophenia, which is basically seeing patterns in random data where none exist, right? So especially with text data, you want to see if you can spot the hidden where's Waldo type thing. But I will say that there are practitioners on one side, and then you have some information about kind of time and medication on the other side. You could do inference there. I think maybe the most important thing is just where tests and expenses, and then what I would say online searches for answers are all kind of in the same domain, kind of hinting at why people maybe would go online and ask questions. So to the actual modeling of the problem, what we're basically trying to do is, for a given query about someone's health, can you generate a typical response? And there's a bunch of different ways to do that, but kind of the minimal viable product. And a few considerations, when you're going and you're trying to propose this to someone to see if you could actually implement it, make sure that it's augmenting, right? So for a bunch of different reasons, you need to convince the doctors that you're going to make them do their job better and you're going to make their job easier, right? it's kind of one of the reasons is same issue with anything else in AI. You don't want to just say like I can do your job and you don't have to have a job anymore. That's not really a compelling argument. Considerations are like number of speakers as we're going into the modeling, change in topic, and outcomes. So the way that, given the data that we have, it was structured is that you have a thread, and then you have responses at different layers, right? So you have like the initial question, I have a cold, some other complications, can anyone suggest something? And then you have like the initial response, hopefully from like a medical professional, right? And then maybe another response to the initial question, and then maybe a third one. And then some people kind of get, like a sub-conversation going. And so basically, there's a bunch of different ways. How are you going to like transfer that into like a modeling system, right? The way I chose was basically, for each initial query, then the next like response, you have a query response pair. So for user 1 and user 2, those first two, the first is going to be the query, and then the user 2 response is going to be the response. So you get, I think, something like n-1 for all the different posts. Those are actually called turns when you have like a switch in the conversation. This is kind of the way it's broken down. So with the final data set, we have like 96,000, which is reasonable for, like a text problem. It's not amazing, but it's decent. I actually trimmed it because you don't want, for each thread, you can kind of consider that a topic. For each thread, you don't want like, for sparsity's sake, you don't want like just a question and then one response, right? Hopefully there's some like dialogue going on, so you get more context from that conversation. So anything that had like less than 3 turns was eliminated. So that's kind of, if you're going to like check the numbers on the slides, that's why there's a discrepancy between that and the previous one. This is kind of what it looks like, a little bit more detail. The initial query, this could be, again, any level, but, all right, give me a bit, any food you can eat, egg products. And then you don't have to read through all these, but I think the answer is pretty obvious. There can be good answers, right? But basically what we're doing is we're taking 10, it's called Retrieval, response retrieval, and you have 10 possible answers, right? And so you can either have between like 1 correct answer and 9 correct answers. And in this case, I'm only showing 4 of them, but there's 1 correct answer, which is I can eat pretty much anything. This is like another view of the data. Basically, you don't have to read through it, but the top part is someone asking a question about their cold, kind of a common question, and then there's 2 initial level responses to that, basically suggesting medications. And then I don't get too much into the talk about like the cleansing of it, but I just wanted to mention some of the things that we would do to extract the health part, right? This is to talk about health. How do you kind of like start to go down more that road, even though it's a data about health, you need to do more to curate that. These are tags from that text you just saw. It's using basically a huge online curated database called UMLS. And basically what you do is go through and extract what are called entities from either phrases or words in order to relabel them. That helps you a little bit with sparsity, right? So if you have like weird medications and diseases, you can kind of relabel those as like a disease or a drug or something like that. Onto the modeling part. So some of the considerations when you're going about this, right? I don't know if anyone's familiar with chatbots. I haven't used that word yet, but obviously that's kind of like in the realm we are. I don't use chatbots because I think chatbots is kind of like I don't know if it's like cool anymore actually. So it's like more textual response, but it kind of limits it to something you would see on like Slack, right? But when you get into that realm, you would start thinking about like generative, a couple different ways of doing that, right? And probably you're going to have at the end of the day a mixture of all of them. The one that probably a lot of people maybe gets maybe is the most impressive, I guess, is like the generative response, right? So if you go to Google Translate, that's using a generative model where it's kind of an encoder decoder system. It's basically the same thing as that's done for the example you see above. I took this from the Keras website, but translating from English to French. But basically, if you have like a given like input, then the model generates on its own a response based on that. That's kind of like a seed. So some of the considerations for that, why it might not be good, is it needs more, those type of models need more data in general. It may not be precise enough for a health context, right? So you're kind of like giving a lot of free rein to the model, right? And when we started off initially, that was one of the main considerations, is that you have to have a lot of control over it. You're already in the deep learning realm, so you can't really like have a lot of explainability either. So some of the, I actually tried running this initially just to see kind of what the response is. So this is like an initial query, kind of like a more like a emotional type situation. Someone just reaching out online, Reddit, docs, I need you, and the response that came back was, I don't think, it kind of cryptic, right? I don't think it's a single plane, as not a doctor, but I have similar symptoms in the story. So the bot isn't like doing very well, right? That's kind of the generalist, like not very caring response that you might expect to get. So the route we decided to go, or I decided to go, is a response retrieval. Basically, what I mentioned earlier is where you have like an initial query, and then you have a set of possible answers, and anywhere from like 1 correct answer up to 9 correct answers, depending on your use case. The reason why that's nice, right, is because maybe there isn't 1 correct answer to the initial query, right? Maybe you want some nuance, or maybe you want an options. If you think about when you're texting on your phone, that's probably some sort of response retrieval where you have some different options to kind of auto include a word that you would want. So you have more augmentation of it. The model, the deep learning model that's running is called a dual encoder. Basically what it is you have your query, you're initializing it with kind of word embeddings, and then you have your response, and kind of both go towards probability at the end, and you're allowing the query to be updated with the word embeddings, and then also the response to be updated in the word embeddings, and then you output the probability. So I used pretty large word embeddings to initialize it. That made quite a difference. I actually tried using like Reddit data just to see if that did any better, and it didn't. But going down the road, something like maybe some transfer learning or something would be a good route to go. So these are just kind of briefly the results so far. And this is, by the way, following like a pretty famous paper. I think I mentioned it a few slides ago. Sorry, I forgot to call it the paper since we were following it. It's the Ubuntu dialog corpus. It's a few years old, but it's definitely kind of like tried and true. The kind of reports that these are kind of following the reports that they did, where they baseline the result. So if you have, say, like 2 possible answers, the metrics are, response at a certain thing. So if you have 1 correct answer out of 2 possible answers, then what is your score at selecting 1 correct answer? So the baseline obviously is like 50%, and use the same thing for 5 possible answers and 10 possible answers. So anything above that is improvement, right? So the initial kind of like baseline model is term frequency, basically what are the most relevant responses to that. So that's already an improvement over it. The kind of baseline model that they set up, which is an LSTM, actually found that the GRU, which is people say use that a lot because it's supposed to be faster, and I found that like it actually improved a little bit. So it's not bad. So future directions, refine the problem statement into one that exploits the potential of the data, right? So can we maybe figure out, select the correct responses based on, which usually like in chatbots, the word that's used is like intent. So can we say for the initial query, like what is the intent of that? So you can kind of further refine the problem statement a little bit more. For the one example we saw of like health, you could classify that as like an intent for people asking about like the flu, for example. So then all the suggested responses that you would give would be ones probably about flu. Whereas like a more complicated matter, maybe you would have to like kind of further refine the problem a little bit more. That's where the UMLS I mentioned earlier would get into, become more important. Experiment on predicting next response given all thread history. So the paper actually included, for a given like thread, they kept track of like each individual and what they were saying throughout that whole thread. I think part of that was due to the data, but it'd be interesting to play with some of those things. And then use like some ideas like transfer learning to kind of further refine the model. So I'm actually going through this a little bit quicker. So I'll just mention, since it's about health, a few details about the UMLS. It's basically information from the past 7 years. And if anyone's familiar with ICD 10 codes, it has things like that. It also has things like information about drugs. But basically, it's divided into 3 sections where you have a metathesaurus, semantic network, and then specialist. So typically, I use just the metathesaurus, where you basically can extract phrases and get any of these from those. And I think that's it. Yes. Are there any questions?
Did you delve deeper into the test errors and, like, as you said, the conditions can have a different response. So basically, flu conditions might give you a better error rate compared to complicated conditions give you a worse error rate in terms of the original problem. Yeah.
So you're asking about like, I guess it depends how you'd want to quantify like an error, right? Because it may not be a bad response. Like if it's so, and it also depends on so maybe an example would be like an online forum, right? So a flu is probably fairly straightforward. So it depends like how you want to kind of like resolve that issue, right? But it's possible that like a simple fever, like it would be easy to say a simple fever is not a problem, but I think if it's not your kidney, maybe your kidney. I think if you've had your kidney out, it's possible that you can develop like a fever from just like a small like allergy even, and probably most doctors would just say that's just like a fever from like a cold or something, right? Like that, right? Well, it could not be, and if they misdiagnose and it's your spleen. So if you have your spleen removed, it's possible you develop a fever, you go in, they just say it's a flu, go home and take some meds, and you're dead within like 8 hours. So it kind of depends, right? Like, do you want to, like, how refined do you want to get on making the error? And then also, like, the error would be like the worst case scenario, right? And so, like, how do you get your test data? So I don't know if that's like helping what your question was.
Right. So I think what you're saying is how do you define error? What I'm asking is, like, this is essentially an automated response to a condition which patient is asking for, right? Mm-hmm. So if the condition becomes, if we classify the conditions, let's say 10 categories, is the response's accuracy different for different kinds of conditions?
I haven't tested that too much.
Okay.
This is just across the like global corpus. So it would kind of depend on like the different categories. So maybe you're thinking of like the different clusters, right? So you'd have to decide like what the different categories are initially, right? Because it's
right. So for example,
test.
on the there was the symptom column in the very first data matrix that you had, where there there was dizziness, nauseousness, and nauseous, and all of those things. And maybe if the symptom being described is dizziness, the response may be more accurate compared to a symptom being described being like something very complicated, then response may be less accurate.
Right.
Yeah.
Yeah. So you'd have to decide. So those were just like words that were used in context, right? So sort of like maybe the easiest would be like flu, and so. Yeah, I think you'd have to decide. I didn't test to distinguish between those because it's still like an open-ended like problem. I think that probably would be part of the next like test, right? And all that would kind of probably be dictated by the initial like post that the person had. So the person that started that thread, right? The conversation can diverge a lot, but that's probably the best way to go about it, and then decide like, are they asking about like a flu issue? Are they asking about something easier like a broken leg? But that's kind of where like you get into like even more challenges also, because then you're trying to decide. So like in the medical world, there's I think somewhere on like what they call like 8 manifestations of symptoms, and so the symptoms that people describe may not like be the actual issue, if that makes sense. So it's like a non-answer, but I'm just trying to get at the idea of like how you would approach that type of problem.
Hi, how often do you retrain your model to keep it up to date then?
So it's not currently in production right now. Yeah, but so it doesn't take very long. It can be trained like on a local computer, like within a few hours actually. Yeah, so this is kind of per my initial like comments at the beginning. This is something that would be taken to like executives or something, or even like outsourced to like a different company potentially, and then come back and we refine that even more. Just because like especially for something like text data, like there's no way really to anonymize that at all, right?
Hey, the clusters on your word embeddings looked really impressive, and so I'm wondering what extra benefit you get from also adding these. I forgot UML or that
UMLS.
Yeah, that taxonomy as features in your data versus like excluding, and then maybe the word embeddings are sufficient.
So you're asking like, did the clusters change at all with or without the?
I guess maybe I'm wrong in assuming you're feeding both as inputs into your LSTM.
Yes.
What happens like if you exclude, say, the taxonomy tags? Are the embeddings sufficient to capture all the information there?
Yeah, it actually does like reasonably well. It does go up. It doesn't go. The difference isn't huge. So the difference in performance isn't huge by adding that taxonomy or not adding that taxonomy. It's probably going to be more useful when you're trying to decide, like kind of the earlier question, like what the intent of like each category is, in order to kind of cluster the different like ideas that are coming across. And the clusters are actually just pretty much on the raw data before cleansing.
I think we have time for 2 more questions. I saw a question over here.
Are you considering interpretability at all as you're working on this?
Yeah, definitely interpretability is like always a consideration, and it would depend on like what like interpretability is. That was part of the considerations of the model, because then you can like enable more decisions, right? So it isn't just generating a response. There's like no choice in the matter. The only way to like really, for like when the generative one, that's like kind of the worst case scenario. I guess you could generate a bunch of different responses and then give the clinician a choice. But with this, you have like pre-qualified answers where they can kind of explain like how, more along the lines of a rule-based system. So you can kind of like basically funnel it in and have like kind of the interpretability a little bit. And you can also, there's actually a really good package called Lime, if you're interested, which is local, I forget exactly what it stands for, but basically kind of doing like a bootstrapping approach. You can highlight different portions of text that contribute towards the response. So that's like definitely an ongoing area of research, especially for deep learning.
Okay, one more question. Anyone have something? Well, that was really informative. Thank you for your talk today.